Hello and welcome to this revision session for AQA A-Level Physics Paper 1. So in today's revision session we're going to look at how we can answer multiple choice questions on AQA A-Level Physics Paper 1. So if we've been successful and we've learnt in today's lesson, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics and understand what topics we need to improve upon for AQA A-Level Physics. So how should you prepare for revision in this particular revision session? Well, when you're completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down any working out answers to the questions in the revision session. When you're doing this, make sure to write your answers in full sentences and show your full working out. Whilst on the right hand side, write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. And after the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-Level Physics? Well, the first thing you should be doing is learning the key facts. Use revision guides, class workbooks, prep notes and the textbook to learn the key ideas of the course. Then secondly, you should be testing yourself. So use things like Caboodle, Seneca and knowledge checkers to quickly test your own knowledge. And then finally, practice examination questions. So use exam prep books, homework books, supervised study books and additional workbooks to answer exam questions and mark your own work. So the three steps of learning the key facts, then testing yourself, then practicing examination style questions are how you should be revising AQA A-Level Physics. So let's now have a look at some multiple choice questions from AQA Physics Paper 1. So the first topic we'll look at is particles and radiation. So electromagnetic radiation incident on a metal surface can cause electrons to be emitted. Which of the following statements is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this first one, the answer is D, because only photons above the work function allow electrons to be emitted from the surface. Now, electrons differ in the energy dependent on where they are at in the metal, and also the range of emitted electrons depends on the frequency of the radiation. So the only correct statement is D. The next question says, in a photoelectric experiment, light is incident on the metal surface of a photocell. Increasing the intensity of the illumination at the surface leads to an increase in what? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this one is C, because when the intensity of the photons increases, there are more electrons released every single second, because the photons and electrons interact as a one-to-one ratio, so therefore if there are more photons hitting the surface, then therefore there will be more electrons released. So if there are more electrons released every second, that will be shown in the current of the circuit, the rate of flow of charge. The next question says, an electron collides with a neutral atom and ionizes it. Which of the following describes the particles present after the collision? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this one is C, because when ionization has occurred, an electron is released and a positive ion is formed, but there's also still your original colliding electron which interacts with that atom at the start. So therefore we have two electrons, the original electron and the electron emitted through ionization, and the positive ion produced when the atom has released that electron. So the answer is C. The next question says, a metal surface is illuminated with ultraviolet radiation. The number of photoelectrons emitted from the surface per unit time and the maximum kinetic energy of the photoelectrons are both measured. The illumination is now changed by increasing the frequency of the radiation and decreasing the number of photons incident on the metal surface per unit time. Which row correctly describes the observed changes? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, our answer is A, because increasing the frequency of radiation will increase the maximum kinetic energy of the electrons emitted, whilst decreasing the number of photons incident will decrease the number of electrons emitted, because the electrons and photons interact in a one-to-one ratio, so therefore the only possible solution is A. The next question says, the graph shows a relationship between the maximum kinetic energy of photoelectrons emitted from material X and the frequency f of incident light. So which line shows the variation of maximum kinetic energy with f for a different material? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer is D, because the gradient of the line is Planck's constant, so that'll be unchanged from x because it's a constant. Now the line cannot be C because the y-intercept needs to be a negative to gain a value for the work function with the metal, so the only possible solution is D. The next question says, a beam of electrons is directed at a graphite crystal. After passing through the crystal, the beam is incident on a fluorescent screen where each incident electron produces light. The photograph shows the pattern observed on the screen. So which of the following gives the two properties of electrons which helps explain the production of this pattern? So pause the video now, then unpause the video when you want to go through your answer. Right, so what's going on is as the electrons pass through the graphite, it is then diffracting through the gaps of the graphite atoms, and then the diffracted waves will then interact with each other via superposition to produce the interference pattern. So our answer is B. The next question says, which line correctly classifies the particles shown? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, firstly, a neutron, you've got to be aware of this, is made up of down quark, up quark and down quark, so it can't be A. The neutron is a baryon, not a meson, because it's made from 3 quarks, so it can't be B. The positive pion is a down anti-up. We can work that out because we need a positive charge and we need a quark-anti-quark pair for it to work, so that isn't correct. So therefore, the only possible answer which is correct is C, the proton. The next question says, which of the following is not made of quarks? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, the answer is B, because a neutron is a baryon, you've got to be aware of that, so it's made from 3 quarks. The pion and the kaon are mesons, again you've got to be aware of that, so they're made from 1 quark, 1 antiquark. So the only thing left is a muon, which is a lepton. Leptons are not made from quarks, they're fundamental. The answer is B. The next question says, which interactions are involved in the production of a strange particle and its decay into non-strange particles? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, our answer is A, because strange particles tend to be called kaons. Now kaons, you've got to be aware, are produced by the strong interaction, yet decay via the weak, which is why they're observed longer than they should be in particle interactions. So our correct answer is A. The next question says, which row shows the correct interactions experienced by a hadron or a lepton? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, you've got to be aware that a lepton experiences the weak interaction only, that is just a fact, whilst hadrons experience the strong interaction because they are made from quarks, and also the weak interaction because everything experiences the weak interaction. So the correct line to use is A. Let's now have a look at some questions concerning waves. So the first question says, which of the following provides direct experimental evidence that light is a transverse wave motion rather than a longitudinal wave motion? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this is C, because it's a fact that only transverse waves can be polarized, which distinguishes them from longitudinal waves. The next question says, which gives the region of the electromagnetic spectrum in order of increasing wavelength? So pause the video now, then unpause the video when you want to go through your answer. Right, for this question, the answer is A. Now you've got to be aware of the order of electromagnetic waves from low wavelength to high wavelength and vice versa from your knowledge of GCSE. So radio waves have the longest wavelength and the shortest frequency, whilst from the options given, X-rays have the shortest wavelength yet the highest frequency. The next question says, white light passes through a single narrow slit and illuminates a screen. What is observed on the screen? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is C, because when white light is passed through a diffraction grating or a single slit, the central maxima is white because there's going to be no path difference there, and the other bright fringes are the colours of the spectrum. Now this occurs because they all diffract slightly differently, so will form at different positions. The longer the wavelength, the more the diffraction, so blue will be closest to the centre and red will be the furthest. So our answer is C. The next question says, a diffraction pattern is formed by passing monochromatic light through a single slit. If the width of the slit is reduced, which of the following is true? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, our answer is C, because when the width of the slit reduces, that will give a central maximum of a greater width, but the intensity of the maximum will increase. The width will increase because if the width of the slit reduces, you get a bigger spreading out or diffraction effect, so that width will increase, but the same amount of light is going through, so if it's spread out over a bigger area, the intensity will go down. So our answer is C. The next question says, a parallel beam of monochromatic light is directed normally at a plane transmission grating with n slits per meter. The second order diffraction beam is at an angle theta to the 0th order transmitter beam. The grating is then replaced by a plane transmission grating which has 2n slits per meter. Which of the following statements is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is C, because we know for a diffraction grating that n lambda equals d sine theta. Now we also know that d is equal to 1 over n, where n is the number of lines per meter. So if the grating is now at 2n, that tells us d is at a half, but it also means that if n is equal to 2, because we're told it's the second order, well then the effects will cancel each other out, of d being a half and n equaling 2. So therefore our first order beam will be at theta, so the answer is C. The next question says, when a parallel beam of monochromatic light is directed at two narrow slits S1 and S2, interference fringes are observed on a screen. Which line in the table gives the changes that will increase the spacing of the fringes? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer for this one is B, because we know that for the double slit experiment, our equation is W is equal to lambda D over S. So this tells us that if S decreases, W will increase. If lambda increases, W will increase. And if D increases, W will increase. So the only correct combination is B. The next question says, the graph shows how the vertical height of a travelling wave varies with distance along the path of a wave. The speed of the wave is 20 centimeters per second. What is the period of the wave? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this one is B, because we know C equals F lambda and F equals 1 over T. So therefore we can sub that in and say C is equal to lambda over T, so T equals lambda over C. Now we know lambda is 4 centimeters from the question. We can work out that the speed is 20 centimeters per second, so they'll cancel through to give us our value of 0.2 seconds. So the answer is B. The next question says, which statement is not correct for ultrasound and X-rays? So pause the video now, then unpause the video when you want to go through your answer. Right, you've got to be aware that ultrasound waves are longitudinal and X-rays are transverse waves. Now this therefore means that transverse waves can be polarized and longitudinal waves cannot be polarized, so our answer is therefore C. The next question says, when monochromatic light source is incident on two slits of the same width and an interference pattern is produced, one slit is then covered with opaque black paper. What is the effect of covering one slit on the resultant interference pattern? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this question, the amount of energy transferred is the same, so therefore our intensity is going to be the same, and the width of both the central maxima and the outer maxima will be unchanged from the fact that we've covered over one slit with opaque paper, because it doesn't affect the width of the maxima, so therefore our only answer could be C. The next question says, when light of wavelength 5 times 10 to the minus 7 meters is incident normally on a diffraction grating, the fourth order maximum is observed at an angle of 30 degrees. What is the number of lines per millimeter on the diffraction grating? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, again, it's diffraction grating. So d sine theta equals n lambda. So we can then rearrange it and find out d. So we'll say d is equal to n lambda over sine theta. So we work that through by popping in the numbers to get 4 times 10 to the minus 6 meters. Now we know the number of lines per meter, big N, is equal to 1 over d. So we pop that in and we get 2.5 times 10 to the 5 per meter. But we want it in per millimeter, so there's a difference of 10 to the 3. So therefore in 1 millimeter it'll be 2.5 times 10 to the 2 lines per millimeter, so our answer is going to be A. The next questions are now on mechanics and materials. So the first question says, which statement about a couple is not true? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, there are coplanar forces as the rotation is in one plane. You'll know that couples can produce rotational motion, that's one of the definitions of them, and moments are equal to force times by distance, so the units will be Newton meters. But translation is motion in a straight line, which does not happen with a couple, so the answer is going to be C. The next question says, two cars P and Q leave from the same point and travel in the same direction. Q leaves at time t equals 0 and P leaves 1 second later. The figure shows the velocity time graph for P and Q. What is the distance between Q and P when t equals 8 seconds? So pause the video now, then unpause the video when you want to go through your answer. Right, so the area under the line of this graph is the distance travelled. So you can work out the area for Q, which is a half times by 8 times by 40, that right angle triangle, so it's 160 metres, and P is equal to a half times by 2 times by 20, that right angle triangle, plus 5 times by 20, the rectangle, which is going to be 120 metres. Now the distance travelled between the two is the difference in the distances, so it's 160 minus 120, which is equal 40 metres, so our answer is A. The next question says 0.20 kilogram mass is suspended from a string. A 0.10 kilogram mass is suspended from the 0.20 kilogram mass using a thread of negligible mass. The system is in equilibrium and the thread is then cut. What is the upward acceleration of the 0.20 kilogram mass at the instant the thread is cut? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that when the object is in equilibrium, as it says this before, the forces up equal the forces down. So if we've got 0.3 times by g downwards, the mass times by gravity downwards, well therefore the force upwards must be 0.3 g. So afterwards we've still got that 0.3 g acting upwards, but we've now got 0.2 g acting downwards because we've removed 0.1 g by losing that 0.10 kilogram mass. So therefore our resultant force is the difference, which is 0.3 g minus 0.2 g. So therefore it's 0.1 g. Acceleration is the resultant force divided by the mass. So it's 0.1 g divided by 0.2, which is 0.5 g. G is 9.81. So it's 0.5 times by 9.81, which is 4.9 meters per second squared. The answer is B. The next question says, two metal specimens X and Y are stretched until they break. Y has a greater Young modulus, a greater ultimate tensile stress, and is less brittle than X. The stress strain curve for X is shown. Which is the stress strain curve for Y? So pause the video now, then unpause the video when you want to go through your answers. Right, so we can tell that from the information that Y will have a steeper gradient because it's got a higher Young's modulus, and the Young modulus is the gradient of the line. Y will have a higher peak because there's a higher UTS, and UTS is the peak of the line. And that Y will also have a greater inelastic behaviour, so the greater curvature, because it's less brittle, and a brittle object is one that doesn't exhibit much inelastic behaviour. So the correct answer is B. The next question says, a lift of mass m is suspended from a cable. The lift descends with a downwards acceleration a. A frictional force F acts on the lift. What is the tension T in the cable? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this particular question, how would you answer it? Well, on the mass, the forces up are F and T added together, and the force down is W, the weight. So we can say the resultant force is W minus F plus T, the difference between the two forces. But the resultant force, as we know from Newton's second law, is always equal to ma. So we can equate the two, and we can rearrange and say T equals W minus F minus ma. W is equal to mg, so it's mg minus F minus ma. So we can then factorize the m out to say m times by g minus a in the brackets minus f, so our answer is D. The next question says, which of the following is a scalar quantity? So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important to know that all energies are scalars. So therefore, from the options given, kinetic energy will be a scalar. The answer is B. The next question says, a student used a balance to measure the mass of a small cube with sides of length x. The student also measured the mass of a larger cube with sides of length 1.5x. Which of the following is the density of the larger cube in terms of density of the smaller cube? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, we can see in the question that the mass is the same. Now we know density is mass over volume. Now we know the mass is now gone from 1x to 1.5x in terms of the volume, but the volume is a cube, so if one side is 1.5x greater, well, there's 1.5x cubed, so therefore it's mass divided by 1.5 cubed, which is going to equal 0.30, so the answer is going to be D. The next question says, a body of constant mass falls freely due to gravity. The rate of change of momentum of the body is equal to its what? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that from Newton's second law that the rate of change of momentum is equal to m times by change in velocity over change in time, because it comes from F equals ma. Now we know that for an object falling freely, that a will be equal to the strength of gravity g, so therefore F equals mg, and we know mg is also weight, so therefore it must be equal to the weight. The answer is D. The next question says, material P has a higher Young modulus but a lower ultimate tensile stress than material Q. Which of the graphs shows the correct stress-strain relationship for P and Q? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, P will have a lower peak because we've got a lower UTS, and UTS is the peak of the stress strain graph, and P will have a steeper gradient because it's got a higher Young modulus, and a Young modulus is the gradient of a stress strain graph, so the correct possible answer is going to be C. Let's have a look at some questions with electricity. So a student set up a circuit as shown below. She varied the resistance of the circuit and the graph shows the results obtained. So which statement is true? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? So we know that there's an internal resistance because V varies with I, which is important. We know that when internal resistance increases, there's going to be less energy transferred to the circuit because we dissipated out of the power source, and therefore the current would go down. We know that the maximum energy transfer does not occur at 12 volts, as to achieve the EMF there's going to be no output in the circuit whatsoever, so that can't be the case. And we know that the internal resistance is the negative gradient of a VI graph, which is going to be 5 ohms, so our correct answer is going to be D. The next question says that 4 resistors, each of resistance X, are connected in a network as shown. What is the total resistance of this network? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question we know we've got a section of resistors in parallel and resistors in series. So for resistance in parallel we know 1 over R total equals 1 over X plus 1 over X plus 1 over X. So therefore we're going to get 3 over X. So therefore when we work out our total, we flip it over, so it's a third X. Now in series, that entire parallel section is then added to the resistor in series, so it's a third X plus X, so it's going to equal to 4 over 3X, so our answer is D. The next question says, the components in circuit X and Y are identical. The cells have a negligible internal resistance. What is the ratio of the power dissipated in circuit X compared to the power dissipated in circuit Y? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer is A, because we know power is equal to V squared over R. Now from this question we know that V, voltage, is the same for both circuits, and that therefore power is going to be proportional to 1 over resistance. So in circuit X we know that R is equal to 2R because we've got 2 resistors in series, yet in circuit Y R is equal to half R because we've got the resistors in parallel. So therefore X will have 4 times as much resistance, and therefore it will have 4 times less power from the relationship, so our answer is A. The next question says, which network of resistors has the largest total resistance? So pause the video now, then unpause the video when you want to go through your answer. Right, for these types of questions, it's important to note that you've got to work out the parallel section and then add them to the series parts. So for part A, you would say 1 over R total is equal to 1 over 2 plus 1 over 4. You can then work that through and then work out R total to be 1.3 ohms. Again, for B, you can say it's 1 over 3 plus 1 over 3. So therefore you work that through to be 1.5 ohms. We then, for part C, work out the section in parallel. So it's 1 over 1 plus 1 over 1 plus 1 over 2. We then flip that over to be 0.4 ohms. Then we add that to the resistor in series to be 2.4 ohms. And then for D, we work out resistance in parallel by doing 1 over 1 plus 1 over 2 plus 1 over 2. Then we flip it over to get 0.5 ohms. Add that to the resistor in series, which is 1 ohm. So our answer is 1.5 ohms. So the biggest value is C. The next question says, the following circuit contains two resistors of equal resistance and a diode. What is the reading on the digital voltmeter? So pause the video now, then unpause the video when you want to go through your answers. Right, so how do you answer this particular question? Well, our answer here is going to be C, because firstly the diode is acting against current flow, so there'll be no current flowing down that path. So therefore, if each resistor has the same resistance, well therefore each output will have the same resistance. So as a result, as the potential difference is proportional to resistance in a potential divider circuit, they'll take an equal share of the EMF. Now if the EMF is 3 volts as stated in the question, and there's two outputs taking it equally, it's 3 over 2, which is 1.5 volts. The next question says, charge plates X and Y have a potential difference of 1.5 volts between them. Which particle gains 3 eV of kinetic energy when moving from Y to X? So pause the video now, then unpause the video when you want to go through your answer. Right, we should know that Q is equal to W over V, and we can then use the units of EV in V to work out our charge in terms of E. So 3 over 1.5 is going to give you a charge of 2E. Now we know a proton has a charge of 1E, a positron has a charge of 1E, an electron has a charge of minus 1E, but an alpha particle, because it's 2 protons and 2 neutrons, has a charge of 2E. So our answer is D, the alpha particle. The next question says, this diagram shows the part of a circuit and the currents in the circuit. What is the potential difference between point P and the Earth? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, you've got to work out what the potential is going to be at P and then after it in the junction and work it out as the difference from the Earth. So we know that the sum of the currents entering a junction equals the sum of the currents leaving the junction. So with P, we know I is 2 and we know that R is 10. So the volts in P, the resistor in P is 20 volts. Now after the circuit, the total current leaving is 6 amps because there's 4 and 2 going in. Now we know V equals IR. We've got current to be 6 and we've got resistance of the resistor to be 20. So we get 120 volts there. Now we know the potential at Earth is 0 volts, that's a fact. So the difference is 120 plus 20 minus 0, which is 140 volts. The answer is D. The next question says, a voltmeter has a resistance of 4 kilo ohms and reads 1 volt for every scale division on the meter. A power supply of EMF 20 volts and negligible internal resistance is connected across the voltmeter and a resistor in series. The voltmeter reads 2 divisions. What is the value of the resistor? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, we know from Kirchhoff's laws that total EMF in equals total PD out. Now the question tells us the total EMF in is 20 volts and the voltmeter out is reading 2 volts as it has 2 divisions and each division reads 1 volt. So that tells us the resistor that's connected with the voltmeter in series must have a value of 18 volts because there's going to be 20 volts in, so 20 volts out. Now this tells us the resistor has a voltage of 18 and the voltmeter of 2 volts, so therefore the resistor has 9 times the PD of the voltmeter, so it'll have 9 times the resistance, as of resistance and potential difference are in direct proportion. So 4 times by 9, which is the value of the resistors, then is going to be 36 kilo ohms. The answer is D. The next question says, a cylindrical conductor of length L, diameter D and resistivity ρ have a resistance of R. What is the resistance of another cylindrical conductor of length L, diameter D over 2 and resistivity ρ? So pause the video now, then unpause the video when you want to go through your answers. Right, so for this question, if the diameter is halved, well then the area is divided by 4, because we know that diameter squared links into area. So this means that if the area is divided by 4, that therefore the resistance must be multiplied by 4, because we know that rho equals RA over L, and rho must be a constant, that's a fact. So therefore our answer is B. The next question says two cylindrical wires P and Q are of equal length and made of the same material. The diameter of P is greater than that of Q. P and Q are connected in series and the ends of this arrangement are connected to a power supply. Which two quantities are the same for P and Q? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, we know for a fact that resistivity is a constant for a material. That's just a fact we've got to know. Now we know V equals IR and rho equals RA over L. So as the diameter increases, this tells us that the resistance decreases. And we know from the equation V equals IR that therefore I will be a constant. So therefore the answer will be B. Let's now have a look at some questions concerning further mechanics. So this question says a simple pendulum oscillates for the same time period as a mass on a spring. Which rho gives the combination of pendulum length, mass and spring constant that produces the same time period in each system? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one we know that the time period is approximately square root m over k for a mass on a spring or square root g over L for the pendulum. Now we can ignore the constants because it's going to be the same for both systems. So therefore, if we can work it out for each one, well for D, well t is equal to the square is 1 over the square root of 0.5 over 50, which is therefore going to be 1 over square root of 0.01, and the t, the value for the time period for the pendulum is going to be 1 over the square root of 0.1 over 10, so we get 0.01, which is going to give our same value. So the answer is D. The next question says a simple pendulum is released from its extreme position and completes one oscillation. Which graph shows the variation of kinetic energy with time for the oscillation? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that the answer here has to be A, because firstly energy is a scalar and can never be negative, and secondly at the maximum displacement the kinetic energy stored is at a minimum and the gravitational potential energy stored is at a maximum, so our only correct answer will be A. The next question says, which graph shows the variation of amplitude A with driving frequency F for a damped system undergoing forced oscillations? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is going to be B, because the dampening has a greater effect at higher frequencies. So this causes our graph to shift towards the lower frequencies, which is shown in B with our peak closer to the left hand side. The next question says two simple pendulums of frequency 0.5 Hz and 0.4 Hz respectively are set into simple harmonics simultaneously and are initially in phase. What's the minimum time to elapse before they are again instantaneously in phase? So pause the video now, then unpause the video when you want to go through your answers. Right, so in this question the answer is C, because the difference in frequencies between the pendulums is 0.1 Hz. Now the time interval of the frequency being in phase again is 1 over the difference in frequency, so it's going to be 1 over 0.1 Hz, so our answer is going to be 10 seconds. The answer is C. The next question says, a 45-gram mass suspended from a vertical spring performs simple harmonic motion. What mass must be added to the system to double the period of the oscillation? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this question we know that t is approximately equal to the square root of m over k. So therefore if k is a constant, then t is directly proportional or approximately equal to the square root of m. So it means to double the time period you've got to quadruple the mass. So this means that the overall mass to get double the period must be 180 grams, 45 times by 4. But because you've already got 45 grams on the spring, you'd only need to add 135 grams to get to 180 grams. Our answer is C. The next question says, a car of mass 1,200 kilograms travels at a constant speed around a horizontal circular bend of radius 15 meters. The car travels from P to Q in 1.8 seconds. What is the centripetal force acting on the car? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question we know F equals m omega squared r, because that's the equation for the centripetal force. And we also know that omega, the angular velocity, is equal to the change in angle over the change in time. We know here that the change in angle is pi over 2 radians, because you can see it's a 90-degree change from the diagram. We know that the time is 1.8 seconds, so therefore our value for omega is 0.87 radians per second. We can then substitute that into the equation for 1200 times by 0.87 squared times by 15, so it's going to be 13707 newtons. The answer is B. The next question says, for a particle moving in a circle with uniform speed, which of the following statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this one is C, because displacement will always occur perpendicular to the force for a centripetal force, that the force is always perpendicular to the velocity, again as is the centripetal force. The kinetic energy is constant because the magnitude of velocity never changes with a uniform speed, so the only possible answer that could be correct is C. The next question says, a bob of mass 0.50 kilograms is suspended from the end of a piece of string 0.45 meters long. The bob is rotated in a vertical circle at a constant rate of 120 revolutions per minute. What is the tension in the string when the bob is at the bottom of the circle? So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this question? Well, we can tell that the resultant force is going to be T minus mg, because mg is acting downwards and T is acting upwards towards the centre of the circle. We also know that because it's moving in a circular motion, that it has a resultant force of the centripetal force, which is m omega squared r, so therefore we can equate the two, and then we can rearrange it and make T the subject, and therefore say T equals mg plus m omega squared r. We can then factorise m out and say m equals g plus omega squared r. We can then pop in all our values. Again, remember that you can work out what omega is by doing the revolution. We've got 120 revolutions per minute, so therefore we know 1 revolution is 2 pi radians. We can then divide it by 60 seconds, because there's 60 seconds in a minute, and we therefore get our 4 pi. We can then pop that in. We know the radius is 0.45 meters, and we get our answer to be 40 newtons. So our answer is D. So that brings an end to our revision session in today's time. So if we've been successful in today's revision session, we should be able to answer A-level physics examination style questions, assess our understanding on A-level physics, and understand what topics we need to improve upon for AQA A-level physics. Thank you very much for watching this revision session on paper 1 for AQA A-level physics, in particular the multiple choice questions. Thank you very much and have a lovely day.